Okay, chapter 9, polynomials and factoring. So put a big header at the top of this section. And we're starting with adding and subtracting polynomials. So we're going to define a few things, and then we'll start to add and subtract larger expressions than you have done before. So, monomial. Let's define a monomial. What do you think a monomial is? Of one something, because of the prefix mono, right?
Yes.
One something. And so we just say it's a term that you would add to some other terms. Okay? And so they can be just a number. What else could they be, though? A variable, good. Or?
An expression.
Like a little expression, like a number with a variable, right? So we might have things that look like this. We might have 7. We could add 7 to something, right? 7 plus, give me something we could add it to.
3.
3, good. So there you go. So those are two different terms. We could simplify them, combine them. X, which term up here could we combine x with?
7x.
7x. And if we did, we would have x and 7x equals?
What?
What would that equal?
What? X and 7x?
Uh-huh.
And that'd be 7x squared.
Well, we're adding.
Oh,
so
adding.
What's the number out here?
8x.
Good. So there's a coefficient 1, that invisible coefficient 1. Could we combine 7x? Okay. Could we combine 7x and 7xy squared? Could we combine those two? Are they like terms? No, they're not, because they have a different pair of variables, right? I mean, this has just an x, and this has 7xy squared. Okay? So it's as though they both have an x, so they have something in common. It kind of reminds me of like Apple. They both are made by Apple, but this is an iPad, and this is a shuffle, you know? I mean, they look somewhat alike, right? But we notice that they are different. We cannot combine them because they have different variable products that are connected to them. Okay? The degree of a monomial. The degree of a monomial is actually the sum of the exponents of its variables, interestingly enough. Okay? So when we look at these examples we have already, like 7, well, let's start with this one. This is easier. X, a single x. What is the number, the exponent that you don't see? When you see no exponent, the number is 1. So we would say this is a first degree. Okay, first degree. And when you see, look at 7x squared, this one here. And so you look at the exponent, and what is the degree of this term? Second degree, right? It's got a 2, right? When we look at this term here, 7xy squared, it's got more to it. It doesn't just have y squared, it has x to the what? 1. First. So we would say that the degree of this is third, right? Because we would add 2 plus 1. Now let's go back and look at this one. This one's kind of hard. You don't see a variable at all. So what would the degree of the monomial be?
0.
Oh, I hear you saying it's 0. Because if there was an x, it would be raised to the 0, because anything to the 0 equals 1, right? And 7 times 1 is 7. It's a constant. So this would be 0. Okay, good. So we're going to make a little table that shows this. So 3, we just said the degree of that would be, if it had a variable, the variable would have a 0, which would make it equal to 1. Good. Go ahead and complete the table. Okay, so here we have the degrees of each of these monomials. Okay, ready, 8th grade? These are not monomials. So I want you to tell me why 5 plus x is not a monomial. Jack?
Because it's not multiplying by anything. Or it's like, it doesn't really have like...
These are monomials.
Yeah.
One term, right? What can you say about 5 plus x?
It's 2 terms.
2 terms, okay. So it's a sum of 2 terms. Can you combine 5 plus x right now? You don't know what x is, right? This is 2... Oh, this is 2 over n, right? 2 over n. There you go. 2 over n, which would equal the equivalent of 2 times n to the negative 1. So this is not a monomial, even though it kind of looks like one. So what do you think one of the rules for monomials is? Aaliyah? Good. Division by a variable or a negative exponent, which is division by a variable. Okay? We have 4 to the a. This is not a monomial because do we know, I mean, do you know what the degree of this is? No. So we have a variable exponent, so it is not considered a monomial. And then finally we have another one that kind of matches up with the second one, right? If we have x to the negative 1, we have again a negative x. Oh, no. Yeah, a negative exponent. So we're going to be dividing by a variable here. So they kind of match up, these two. This one just looks different when you write it as a fraction. Okay? Okay, so if those are monomials, what do you think a polynomial has? 2 terms or 3 terms or 4 terms or whatever. More than one term, right? Okay, so sum of monomials. Okay, so we will classify polynomials in different ways. One way is by degree. So when we look at this polynomial, this example, x squared plus 7y, x squared is what degree? And 7y is what degree? First. So we would say, which one is greater? Second, and we would classify this entire polynomial by the highest degreed term. Okay? So the greatest degree of its terms. We don't add them. We don't add 2 plus 1 in that case. We say which one has the greatest degree, and it's the x squared. So we would classify it as a second degree polynomial. You might be asked what the leading coefficient is of a polynomial. And you all know what a coefficient is, right? So in this example here, what is the coefficient for x squared? 1, good. What is the coefficient for 7y? 7. And so when you put a polynomial in standard form, you put the highest degree term first. The exponent with the highest degree, right? And then you trail down to maybe a constant at the end. So when you do, the leading coefficient for this statement would be which coefficient is first? Which coefficient is first? It's 1. So the leading coefficient in this statement is 1 because it came with the highest agreed term. You look for the highest agreed term and take its coefficient. That's the leading coefficient. Oh, it's too bad it's showing so much. But anyway, we'll look at this one here. Oh, I see what I'm doing. Okay, I'm showing too much. But let's go ahead and put this polynomial into order from greatest to least degree. And then we can identify at that point the degree of this whole entire polynomial and the leading coefficient, right? So right now you can see that the terms are not in order of highest degree. So rearrange them carefully. What would the first term need to be here, Oscar? Term here has the highest degree variable. To the 4th. Good. So he's pointing out this, and he said, if you didn't hear it, he said negative, which is true. When we move terms, we're using what property of math? Commutative property of addition, right? And so we have to take the sign along with the term. So we would put this term first. The next term would be which term? Matthew? Good, 3b to the 3rd, and then the final would be b squared. So now when we have it in order of degree, there you go. So if we were to classify this by degree, what degree would we call this polynomial? Which is, it's the highest, right? So it's a 4th degree. Good. And then what's the leading coefficient of this polynomial? -4. It's the number that comes before the greatest degree term. Okay, so there you go. It's a 4th degree polynomial, and the leading coefficient is Okay, I don't want you to take the time to write it since it's a short lesson, but look up here. Classify the polynomial by the number of terms. Okay, so if it is a, let's see what I have here. If it has one term, we call it a monomial. So if it has two terms, you've heard me use this phrase, but we haven't used it a lot. You remember what it is? Two terms is a, good job, binomial. Three terms is a, and four terms is a, no, it's a four-term polynomial. Once you get to four, they don't really have a name. I know you feel like you should say quad. Good for you for knowing your prefixes, okay? But it's just a four-term. So eighth grade, if it has five terms, what would it be?
Five terms.
Six terms, seven term, and so on. Okay? We don't name it. Okay, so here's a question you might have today. Tell whether this expression is a polynomial. If it is, name its degree and classify it by the number of terms. And if not, tell why not. You don't need to write these instructions down, but I want you to try it here. Whoop. Whoop, 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 whoop. Here we go. Here are your examples. So write these examples down, 1 through 5. Tell whether it's a polynomial. If yes, name its degree. And classify it by number of terms. And if no, tell why it's not. So pause the video, come back and check it out. So 5xy squared, is that a polynomial?
Yes.
Yes, it is, because a monomial is a polynomial. But is every polynomial a monomial? No. So it's kind of like square rectangle, right? And what is the degree of this polynomial? No. Third degree, good, because x has an exponent of 1, right? 5 would have an exponent of 0, I suppose, if it had a variable. It's a constant, so it doesn't have a degree, okay? And how about 2a to the negative 5? Is that a polynomial? Good job. Why not, Aaliyah? Good job. So we're dividing by a variable. How about x to the 4th plus 3x cubed minus x? Is that a polynomial?
Yes.
And what's the degree of the polynomial? What's the degree?
8.
No.
4.
4. Good job. Why is it 4, Jack?
Because that's the leading.
The highest degreed term is 4, right? And what would the leading coefficient be?
1.
The leading coefficient out here, 1. Good. And classify by number of terms. 1, 2, 3. So this is a, that's degree. Now, this is a 4th degree, and it has 3 terms. So is it a, good job, trinomial. 4th degree trinomial. A over m, is that a polynomial?
No.
Good job, we're dividing by a variable. Now how about 6a squared c plus 5ac to the 5th? Is this a polynomial? Yes. And what is the degree of the polynomial?
9.
You're adding too much, Kate.
2.
You look at the one term that has the highest. What is the degree of this term here?
2.
No, there's an exponent here, so this is 3. What is the degree of this term here?
6.
6. So the degree of the entire polynomial is 6. The highest agreed term. It's the highest agreed term. You look for the one monomial with the highest degree. And classify it by the number of terms. How many terms? So it's a binomial. Good. 6th degree binomial. Okay, so be careful with that practice today. When it comes to degree, you're looking for the one term with the highest number of, sum of exponents. And then the number of terms is easier. Okay? This is what we're going to really spend time doing, though. It's adding, subtracting, and so on, polynomials. So let's try adding polynomials. When we add them, we simply add like terms. The error would be to add unlike terms, right? Okay, so if there are 2 methods for adding, and you should feel comfortable with both. It's the same with your day-to-day numbers. You can add them vertically, or you can add them horizontally. Okay, so let's write them down. Let's write down these 2 expressions that we're adding, and we'll do it both ways.